right now, but it doesn't really matter. I'm always interested to hear about your experience with writing plugins. And if you have any other question around Gradle, certainly let me know as well. So just a couple of words about myself. I've been working with the Gradle team for about 5 years. Been a Gradle Inc. employee back then until summer, and recently decided to go independent. So I now have my own company. I do independent software engineering, training. I'm also working on some things with O'Reilly in terms of training and writing. So you should be seeing some new content coming up. And if you want to follow me, feel free to follow me on Twitter, GitHub, or my blog. I occasionally write about Gradle kind of things, but also anything around project automation, containers and containerization, as well as continuous delivery. So certainly check out the link, bmuschko.com. That's my blog. And if you wanted to have a look at my company and all the offerings that I provide, that is Automated Descent here. And the company also provides some trainings for Gradle. So I have one training online that teaches you how to use the Kotlin DSL. And I also have another course online that is a full day course on plugin development with Gradle. So if you wanted to dive deeper into that with a hands-on kind of like approach, certainly let me know. So when I was starting to dive into Gradle more deeply, that was a couple of years ago. Actually, in fact, I would say almost 8 years ago. So it's been quite a while. I've been a user from the beginning. And what I noticed pretty early on is that writing build scripts is great, but we want to break down the logic in a certain kind of way that makes it reusable. So what I noticed is, well, I need to, let's start a Tomcat server and things like that. I can code all of that stuff in my build script, but what should happen if I also want to have the same kind of functionality in a different Gradle build? So I was actually working on multiple projects, and on the first project I was trying to bring up a Tomcat server. I wanted to do that in another project as well. Both of them were web applications. So what happened is that I first wrote the code in a build script. It was pretty hacky. My build script became fairly long. And what I did in the end is to think about how to make this reusable logic. And the main concept that we have in Gradle to write reusable plugins is the concept of plugins. So it's pretty similar to what you might already know from Eclipse or other plugin systems, for example, Jenkins. You can basically have a self-contained functionality that you can plug into different environments. And the same thing is true here in Gradle. We can write plugins in different kind of fashions. And when I talked about writing build scripts, I was pretty naive in the beginning. I was looking around online and everybody told me it's fairly simple to write Gradle plugins. So I dove headfirst into writing the plugins. And fairly quickly, I actually encountered some issues because in the beginning of Gradle, there was not too much support for certain situations that we'll talk about. And over time, I noticed that there are some best practices that we can actually externalize and formalize in a certain kind of way. So it makes it easier for everyone to actually write reusable logic. And how I want to split up this talk is in 2 different sections. Section 1 will talk about the design concepts that you think about upfront before even writing any line of code. And then we'll dive into the actual concepts by writing code. This is not a demo-driven talk, but I will show you some code on the slides as well. So why is designing important? Designing is important because we have to take under consideration certain aspects that are important before writing the plugin, because they will have a significant effect on how we write the plugin, what kind of language we use for writing a plugin, and what kind of issues you want to solve with your plugin. So let's first talk about designing a Gradle plugin and what goes into the thinking process. So if you looked at Gradle plugin development before, you might have noticed that there are 2 different types of plugins. Plugin type 1 is a script plugin That is pretty much just a plain build.gradle file, just with a different name. And what you can do is you can basically merge together multiple of these plugins. They're called script plugins, and they basically form a overarching build file. You can think of it as the composition concept here. So we have, let's say, some functionality for publishing or some functionality for documentation. And they can be added onto your main build.gradle file. With script plugins, you can also share this logic if you want to. You can put it on an HTTP server if you want to do that. But usually the preferred concept for writing reusable logic is a binary plugin. So what's the difference between a script plugin and a binary plugin? You might already be able to tell from binary plugins, well, it's a binary, so we have to create some code for it. And that code actually lives in basically classes. So what you will end up happening is that you compile your code and it ends up being in a binary file. And in the Java world, that's usually a jar file. And with the help of a jar file, we can actually bundle certain logic. We can basically break down the logic in a meaningful, maintainable fashion. That means we can write different classes. We usually have a single entry point, and that single entry point is a implementation class that implements the plugin interface. That is provided by the Gradle API, and everything else you can basically start from there by just dealing with the injected project instance. So when we compare script plugins, binary plugins, I usually recommend writing a binary plugin right away, simply because you can write your code in classes. And those classes can be organized in packages. Usually what you do, or what you can do, is that you get started writing classes within the build script, but later on you should break out that logic into a separate standalone project that can later on be bundled in the jar file. So when you get started with writing your own plugins, my recommendation here is binary plugins, simply because you can break it down into maintainable chunks, and we can later on write tests for it as well. Writing tests is not necessarily that I will cover something that I will cover in this talk, but there are other good resources online that help you get started with writing tests for your own plugins. One aspect that's fairly important when you write your plugins is the non-functional requirement of performance. So anything that you can write in the Gradle build script can also be packaged into a binary plugin. And of course, depending on when this code is being executed, it might have some sort of impact on performance. So as soon as you apply a plugin to a build script, that basically means all the logic in your implementation will be applied usually upfront. So when you create tasks in your plugins, or if you configure other plugins from your plugin, then all this logic will be executed as soon as you actually apply the apply statement. And the more expensive in terms of performance that logic is, the more your plugin has an impact on your actual build execution times. So always keep that in the back of your mind. Try to not necessarily put in too much code that is being run during the configuration phase of the Gradle build lifecycle, because that's always being run when you execute a build. Try to move as much as you can into the actions of a task that should be provided by the plugin. So keep that in the back of your mind once you get started with writing plugins. There's a pretty good guide on improving and optimizing Gradle build performance. That's not necessarily specific to just writing plugins, but in general. So if you're dealing with a Gradle build, you might actually want to figure out what helps performance, what helps with improving it, and what kind of aspects and concepts will have a certain impact on your build execution performance. So check that out. I would highly recommend reading up on that because it's fairly important to always keep that in the back of your mind. Build execution performance is important simply because you might run your build 30 times as a developer, or maybe 50 times per day. Just think of the usual workflow that you go through as a developer. You might actually want to compile your code. You might want to package your application jar file or WAR file. You might want to run your actual application and other things like that. You usually do this over and over again, running tests. So whatever you apply in terms of plugins will, of course, impact the performance of your build overall. So if you kind of run into an issue with performance, or you don't necessarily know if you have a performance issue, I would highly recommend having a look at build scans. Build scans is a free service that is provided by Gradle Inc. And what a build scan does, it gives you deep insights into your build. It basically breaks down how long it takes to execute your build in different phases. As you might know in Gradle, we have different build phases that we run through with every execution of your project. That is initialization phase. So everything that needs to be set up and scanned before you can run the build. We have the configuration phase. Basically, pretty much all the logic that you have in your build scripts will have to configure other domain objects in your build. For example, if you have tasks, those need to be configured. If you define dependencies in your build, that needs to be configured. That's usually executed during the configuration phase. And then later on, we have the execution phase, which actually executes the tasks of your plugins, if you provide a plugin. And the build scan can give you deep insights into all of these phases that I just mentioned. It also gives you additional suggestions on how to improve performance. Keep in mind, the build scan is completely free of charge. There's an enterprise version as well called Gradle Enterprise. It gives you additional features that you usually don't have in the free version. But if you wanted to get additional insight into your build, that's usually a good place to get started. So build scans, check it out. It's certainly pretty insightful and gives you the hotspots of performance for your plugins. If you do notice that there's an issue with performance, then Gradle also provided an additional tool to actually measure how long it takes for certain phases to be executed. And additionally, if you wanted to make sure that whatever you change in your build or your plugin actually has a positive impact on your build execution performance, then the Gradle Profiler would be a good tool to get started with. So the Gradle Profiler, again, is a tool that has been used for optimizing Android builds mostly. So the Gradle Inc. team has been working with the Google team to identify hotspots here and also make sure that we actually improve something over time. What it basically spits out are metrics that you can load up in any profiling tool, for example, JProfiler, and have a look at that. And over time, try to measure what has changed and see if it actually has a positive or negative impact on your performance, because we all know that without measuring something, we shouldn't prematurely optimize any code that we're dealing with. One of the concepts that you might actually know from other frameworks, from other tools that also applies to plugins is convention over configuration. So what is this? Usually when we write our own plugins, we want to make sure that it's as easy for an end user to use your plugin and to configure it as possible. And for that, usually we introduce so-called conventions. That means we have sensible defaults for your plugins. For example, where to look for Java source code for compilation, or where the output of a build should go. These are all specific conventions that are already provided by a Gradle build. And you can do the same thing. You can use the same concept when you write your own plugins. You can provide certain sensible default settings out of the box that the user doesn't necessarily have to configure. So conventions are awesome. I think they are pretty helpful to keep the configuration in the build script small. But what if you don't like these conventions? You should always give the end user the option to also configure these conventions that come with your plugin. So you can actually have both things, so the best of both worlds, provide conventions so that a user doesn't have to configure something. But if a user wants to reconfigure something, then you can. And that concept is called convention over configuration. Let's have a look at a example that makes it more clear how this looks like in practice. So let's imagine you would have written a plugin that generates a site for your project. That site can potentially contain, let's say, information about the plugins that you apply or the tasks that are available in your project. And it basically produces a PDF or HTML web page. That's pretty much the purpose of this plugin. And what you can see here is that we basically have a binary plugin. That binary plugin implements the plugin interface. And we're basically working on the project instance. So the project instance is basically the topmost domain object in the Gradle build. It represents your project. And on that project, we can add additional things. For example, we can add tasks, but we can also add a so-called extension. And an extension is pretty much a way to expose a custom DSL. We'll actually have a look at an example pretty soon. So envision that we wanted to make our site plugin configurable, and we do that with the help of a so-called extension. And the extension can already set some default values here. So for example, if we wanted to say for our plugin, when you generate your site, then please put the output into a output directory. And that output directory should sit in the build directory plus the subdirectory docs/site. So that's our default convention here. The default convention is useful. It's already been set when you apply the plugin. And in practice, how this can look like is that we expose a so-called extension. You can see that we used the namespace here before. So you can see here on the 1, 2, 3, fourth line in this plugin, we use a specific namespace, which is called site. And that site basically evaluates to this custom DSL that you see on this slide here. Usually, the end user doesn't have to set any defaults, but if you wanted to reconfigure the defaults, as you remember, the default was somewhere under the build directory docs/site. In this case, the user actually overrides the default value by using this extension. So you can see that we use the custom DSL. We assign a completely new value to the output directory property. So that's a means to basically reconfiguring the default values. And you can see there could be other properties, for example, a website URL that is being used in the output that we're generating. For example, we create an HTML page, and that HTML page should contain a website URL that you can refer to. Or, for example, we could provide a version control URL and other things. Anything that you can really think of can be made configurable. What you see though here is that we apply a plugin and we don't necessarily know how the plugin actually operates under the covers. So in this case, it will be able to produce a HTML page or something else that you might want to make configurable, but the user doesn't actually know how this happens. The user only declares what should happen. Basically, on a high level, we can say this should go to this output directory, and we might want to provide additional information from our end, but we don't necessarily need to know how this is being implemented. That's one of the benefits of plugins. All the imperative logic is basically hidden in the plugin implementation. Another concept that you might want to consider when writing your own plugins is capabilities versus conventions. So what does that mean? Usually capabilities are high-level concepts that we might have in Gradle plugins that you provide to a project, whereas the conventions, again, work on these capabilities. They reuse a general concept and already either create an instance of it or they provide certain conventions as we've seen before. So let's have a look at a specific example here. One plugin set that already uses this concept in Gradle core is the Java plugin. So you might know, if you already dealt with Gradle build scripts, that the Java plugin lets you build Java projects. So it already provides the conventions that you need for building and compiling Java code. For example, it gives you a compilation task. It provides you with a task for creating a job file. It already knows how to produce Java docs and things like that. All of those are conventions, and those conventions already define where to look for source code, where to put the jar file, where to create Java docs and things like that. So those are typical conventions. But what you might also know is that the Java plugin also works on another plugin. Basically, it applies another plugin which provides the capabilities. So what are capabilities in this case? Capabilities could be things like custom tasks that are provided. For example, there could be a custom task for compilation. There could be a custom task for generating Java docs and things like that. And there's also an additional capability which is called a source set, which is also applied by the Java-based plugin. So source set basically is a pointer to source directories. And what it does out of the box, once you configure it, it basically provides a compilation task. Out of the box, you don't actually have to write it yourself with the right conventions provided by the Java plugin. And you can basically apply the same pattern in your own projects as well. So how do you actually implement that if you write your own plugins? So let's say we're going back to the site plugin. And down here on the bottom, you actually see the plugin that provides the conventions. That could mean we already produce a task and provide a task that knows how to generate the site with different output formats. For example, you could provide a HTML site or a PDF site and things like that. All of these conventions are already provided for us as the end user. And what you can see on the third line here is that we can also apply other plugins. So we can apply plugins from plugins, and those other plugins basically can provide additional functionality. So if you want to separate capabilities from conventions, then this composition concept is pretty helpful. So basically try to separate capabilities from conventions, so you can always make it easy to maintain, but also for an end user, they can decide whether they want to go with the conventions or if they just want to get started with their own capabilities and build on top of that. So let's imagine you wanted to build your own site plugin for whatever reason, then you can basically build your own conventions on top of the actual capabilities. You can see this concept has been applied here as well. The site plugin basically builds on top of the capabilities provided by the base site plugin. So just keep this concept in mind when you write your own plugins. It's not necessarily something that you have to use per se when you write your own plugins, but if you wanted to break up capabilities from conventions, then that's a good way to do it. So before we even get started writing plugins, we have to think about the language that we want to use. As you might know from Gradle plugin development, if you've done this before, Gradle is built on top of the JVM. And any plugin that you write can basically be written in any language that can be compiled down to bytecode that can be run on the JVM. What we usually recommend here is that you use Java because it has the best backwards and forward capability. But nowadays, people actually look into other languages. For example, Kotlin has become fairly popular, especially in the Android community. But also for writing plugins, I've seen a bunch of plugin developers now mostly use Kotlin because it's considered somewhat the better Java nowadays. In the beginning, many people thought that Gradle can only work on Groovy. That's not really the case. Actually, most of Gradle or the Gradle code base is built with Java. But if you wanted to use Groovy for its dynamic functionality and capabilities, you can also use Groovy. Overall, I would say prefer a statically typed language because then you already have the typing in place. And if you go with Groovy, then make sure that you also use the @compile static annotation because that basically tells the compiler, the Groovy compiler, to check for the types once you compile your code. So if you write your own plugins, you have to make sure that you actually have access to the Gradle API. We've seen that we can operate on a project instance. The project instance is part of the Gradle API. So once you set up a standalone project for plugin development for your own plugin, then we have to apply the Gradle API. And there's a shortcut for it, a dependency shortcut called Gradle API here. And we have to tell Gradle that this is a dependency of our plugin project. So in this case, we use one of the new configurations here called implementation. That's very similar to compile, except that it basically says we need this dependency for compilation, for compiling our production source code, but we don't want to necessarily export this dependency when we publish the artifact. Just one thing that I want to mention about Gradle API, about the shortcut, it really pulls in the whole Gradle API. That means not only does it pull in the public API, which we most of the times want to use, but it also pulls in the internal API. And be cautious with using the internal API, because any API that is part of the internals of Gradle can change with any of the upcoming versions of Gradle without any notice. Because usually the internal API is considered to be something internal to Gradle that you actually shouldn't use. Even though sometimes you don't have a better option, you have to just revert back to the internal API, because otherwise there's just no representation in terms of the public API that we have in Gradle. One thing that I want to mention, and that's not necessarily, I would say, a hard requirement for writing a plugin, try to minimize external dependencies from your plugin to something else. I know that if you write your application code, you will most of the times pull in 1 million dependencies. For example, Guava, Spring Framework, what have you. But it's usually better for a plugin not to depend on too many external dependencies. And there's a good reason for it. This is more a shortcoming of Gradle, I would say. Right now, when you run your plugin in Gradle or in a Gradle build, it's not necessarily isolated in terms of the class path. So one plugin can basically bring in external dependencies that it depends on, including all of its transitive dependencies, but those are not loaded separately in the class loader per plugin. So let's say you have another plugin that also pulls in a different version of a external dependency that you already use in your plugin, then those versions could overlap and you might actually end up having 2 different versions of the same dependency on your class path. And that's usually not desired. I would suspect that Gradle will fix this issue in the long run, but we'll see. And for that reason, for now, I usually try to minimize external dependencies that I depend on from my plugin. So if you wanted to figure out what kind of dependencies you're pulling in with a specific plugin, then there's a built-in task that you already have in Gradle, in any Gradle build, which is called build environment. And the build environment basically pulls in the whole dependency graph of a plugin. And you should be able to see that with the help of the configuration called class path. That is basically the class path for your Gradle project, and it basically contains all the dependencies that are being pulled in by external plugins, by plugins that you have in Gradle in general. So let's say you assign additional dependencies for your project, then you would see them as well. And you can see there could be a whole graph of dependencies, and we want to be cautious about what we're actually pulling in. So my general recommendation here would be try to keep it as small as possible. So these are the design concepts, considerations that we should keep in mind even before we write any code. But now we're kind of ready to actually talk about some implementation aspects. So let's talk about implementing a plugin, what kind of challenges that you might run into, and what are some of these best practices that I mentioned in the beginning that we should apply when writing plugins. So first of all, I think the first thing you should do when you write your own plugins is to apply the Java Gradle plugin. So what is the Java Gradle plugin? This is a plugin that helps you with implementing plugins for Gradle. And what it basically does is that it provides already some conventions, so we're back to conventions here again, that help you write plugins in Gradle. It sets up, for example, testing. It provides a verification for your tasks that you're writing. So let's say if you forget about annotations that should apply to tasks, then those are being checked. It already provides some additional dependencies. For example, the Gradle API is being pulled in automatically, so you don't have to repeat this code. So overall, this plugin basically gives you a way to reduce your boilerplate significantly. So always do this as the first thing. What we should do when we write tasks that are provided by a plugin is that we should think about how to basically separate the imperative logic from the actual logic that allows an end user to operate on it. In this case, the concept here would be a custom task. A custom task is basically a task implementation in a class. And the benefit of writing custom tasks is that we basically have the imperative logic separate from all the declarative things that we can assign from the build script. So in this case, let's have a look at an example. Up here, we can see that we import a class. That is our task implementation, the custom task that could be provided by a plugin. And then we can basically create multiple instances of that type if we need to. So you can see task generate default site basically just operates on the conventions that are provided by this task. We don't provide any additional configuration. We're basically assuming that the conventions are sensible. But given that we also have a custom task here, we can write additional task in a build script if we want to, and reconfigure the defaults if we need to. So you can see here, a custom task is basically a reusable concept where we can instantiate multiple instances of that type. So down here in generate site with custom values, we can again provide some additional configuration from our end. If we want to, for example, output dir could point to a different one than the ones that we provided as conventions. And down there, you can even see that we can make this very DSL lookish. So down here, we have a custom data, which again has a closure that can have some nested elements. So however you want to formalize the way you want to make this configurable, you can. You have a lot of flexibility. But in an essence, keep in mind, writing a custom task is a good idea because it usually hides all the imperative logic. If you look at this build script here, there's nothing that actually tells us as the end user how this site is actually being generated. That's something that is basically happening in the custom task implementation. So I just showed you an example of one of these DSLs that we can expose as part of a custom task. But we can also expose this on the top level of a project. Down here, we have a site that lets us provide some custom data for our site generation. For example, a website URL, a version control URL, and things like that. These are all things that you can make configurable as needed. And you can see this can either be provided on the top level of a project, but also on the level of a custom task. So how you want to make this configurable, up to you. Usually the better option is to make this configurable on the level of the project with the help of a so-called extension. That's pretty much the equivalent to what we've seen in one of the earlier slides, where we basically exposed an extension to expose this custom DSL. So it's fairly easy to assume that every end user will use the Groovy DSL in Gradle, but that's not really the case. You might have heard that Gradle now also exposes a DSL that lets you use Kotlin. So I would recommend not using necessarily Groovy types to model this DSL. This is a better option than using a closure. That's usually a built-in type that we have in the Gradle API called action. Or if you wanted to go for the Java type, which is called callable, then you can make sure that your plugin can be configured from different DSLs that are being exposed or available in Gradle. That means we can use it from the Groovy DSL, but it should also be usable from the Kotlin DSL. So try to go back to other types than closures to make something nested. So what basically happens under the covers if you use an action instead of a closure is that Gradle will recognize this as something that you want to use as a nested element. So for example, let's say we have a method called custom data, which lets you provide an action. Then Gradle will internally coerce that type into a closure if you use this from the Gradle DSL up here, which is shown in the build.gradle. So you don't necessarily actually have to provide a closure. You can actually use an action, which in turn makes it possible to use the plugin from the Kotlin DSL as well. So usually that's the better option. While we're talking about custom tasks in Gradle, we certainly want to make sure that incremental build functionality is enabled for these custom tasks. That means if a task has been run before and nothing has changed in the meantime, then we don't actually need to actually rerun the actions of that task. And that's usually a big boost for performance again. And it's a built-in capability that we get out of the box. It has been around for quite a long time, but if you write plugins as part of your, or if you write custom tasks as part of your plugins, then make sure that you already enable those properties and these tasks to be incremental. So let's have a look at one example here. Here we have a custom task implementation. By default, that means we are extending default task. And as part of making the task configurable, we also expose certain properties here. So up here, we can see that we have an output dir property and a custom data property. And to make those enabled for incremental build functionality, we have to add the annotations that are provided by the Gradle API. In this case, we say, well, the output directory should be an output directory and should be treated as such. And that's why we assign an output directory property, in this case, an annotation, which basically tells Gradle if you want to check for incremental build processing, then make sure that you look at these annotations. The output directory points to a specific directory. If nothing has changed in the meantime from the previous run, then don't rerun it again. Up here, we have also an input property called nested. That's basically a POJO, which again can provide additional annotations and input properties. But make sure that when you write your custom tasks, always provide input and output properties. And in those cases, annotate them with input and output annotations, which basically then tells Gradle to create a hash from these properties. And basically, when you run it for the second time, it will compare these hashes. If nothing has changed, then the action of the task doesn't have to be a rerun because we basically know nothing has changed in the meantime. When you write your own plugins, you will fairly quickly notice that some of these properties or some of the logic that you have in your plugin should be not evaluated when you apply the plugin itself. We should usually defer some of the evaluation to a later point in time. That could mean evaluate something when the actual task of a plugin has been executed, or to a later point in time where you actually could capture some information in the build script. And that's usually what we call lazy evaluation of properties. We've already seen some of the properties actually in the previous example. What you usually are dealing with in a plugin when you write it is that you want to capture some information about how the plugin should behave at runtime from the end user. We've seen that we exposed an extension before, which is basically a DSL representation for the end user. The end user can say, I want to override the defaults provided by this plugin. But to do that, we have to capture it somehow. And we've learned that capturing user-provided values can be done with the help of a so-called extension. But what should happen is that we should wait until the whole build script has been parsed before we actually use those values. So those user provided values usually propagate down to a different domain object. Let's say we wanted to use these user provided values when we run a task. And that task should basically use these property values to assign these values to properties in the custom task. Then we don't want this to happen right away when we apply the plugin. We actually want to wait until we encounter the DSL that has been exposed by the plugin. And when the user actually defines these values for this DSL, only then we want to capture these values and then later on use it when we actually execute the logic. So there's some thinking involved here when we want to capture values and then later on apply it. It shouldn't apply right away because otherwise when we apply the plugin, the values wouldn't have been captured yet. And that's a typical situation that you might run into when writing your own plugins. So how do you implement that use case? I believe in Gradle 4.0, we introduced some additional property types and provider types. For example, up here, you can see a directory property, which is part of that API that lets you define lazily evaluated values. Directory property basically says this is a file type that points to a directory. And this guy should not be evaluated until we actually want to use it. So we can assign values during the configuration phase in Gradle when we run the build. The actual value is not being evaluated until we actually run the task action. You can see in the task action down here in the generate method, we actually call the get output directory method, which actually will get the value of that property. You can see the get method call basically retrieves the value and gives us the file representation of that property. And you can think of these property types or provider types similar to the optional in Java. So it's basically a container of values that are basically set at some point of time, but can be retrieved at a later point of time when you actually call the get method. So fairly similar in terms of functionality, except that we have specific types. So we don't necessarily just have one specific property type for directories. We actually have a whole bunch of different property types that represent different kind of like input and output properties. For example, there's one for a regular file, there's one for a string, or like a property that lets you basically represent such a lazily evaluated property for a string, and pretty much any other type that you might have. So when you write your plugins, it's fairly simple to apply other plugins. We've just seen this in terms of the capabilities versus convention concept. So we can basically apply a plugin from another plugin. That's usually something we should avoid or wait until we actually encounter the fact that we actually want to react to a plugin. So what you sometimes see in plugins is they just apply a bunch of other plugins because they somehow want to reconfigure them. But it's usually better to basically say, if the project that applies our plugin also applies another plugin, then react to it. Otherwise, don't just blindly apply a bunch of plugins, because that again has an impact on performance. So any other plugin that you apply from your plugin will of course configure all the code that's part of that plugin. And again, that has an impact on build performance. So try to defer that. And the better option is to basically react to whether a plugin has been applied or not in a consuming build script. So here we basically say, if the Java plugin is applied, only then configure the Java plugin. Don't necessarily just apply the Java plugin and work on its conventions or its domain objects that it exposes. So we can see here, we can say project, give me all the plugins that are part of this build script. If you encounter the plugin of type Java plugin, then configure it in a certain kind of fashion. And that's a good way to basically defer the configuration logic, but also only react to some logic that actually has been applied. When you write your own plugins, you can apply plugins either by type or by identifier. Usually the better option is to apply plugins by an identifier. That's the typical way of applying plugins that you usually find in the Gradle documentation, but also in external plugins, in the external documentation. You can see here, it's fairly easy to introduce such a plugin identifier. We can define the plugin identifier with property files that basically point to the plugin implementation class as a value. You can have as many property files and plugin identifiers as you want to as part of your jar implementation. Whatever you bundle here should make sense. One good recommendation that I can give you here is to also add a domain. So you can see here, .com/GitHub could be a domain. That's basically where you host the plugin. So try to make it unique so you don't have an overlap in terms of the plugin identifier. Because you could imagine that there could be some sort of side plugin that has been written by somebody else. You don't want to necessarily end up with a situation where you have the same plugin ID from different plugins. That's something that we should usually avoid. So that's pretty much what I wanted to cover in terms of the best practices. There are certainly some gaps that are still out there for plugin development. So what I want to talk about in the last section of this talk is what could be improved in the future of plugin development. And hopefully the Gradle Inc. team will work on those. First of all, what you oftentimes will notice that there are some internal APIs that are useful that you might actually use from your own plugins, but that is usually not recommendable. That's something that I mentioned in the beginning of this talk, is that you shouldn't necessarily depend on internal APIs that are provided by the Gradle API, even though sometimes there's no better option than to do it. But here's the top 10 internal APIs that other plugins might already be using. So we did a simple search here on GitHub for plugins that are implemented for Gradle. You can see the count of all these internal APIs that are actually already out there being used by external plugins. And you can see those are usually pretty good candidates to make them public. So in the long run, hopefully the Gradle team will take some of these APIs and make them public, or give them a public API representation. There are some public APIs that have a fairly big impact. So hopefully in the long run, the Gradle team will provide an API to separate internal and public API. So we can basically say in a plugin, I only want to apply the public API, and then make a deliberate decision potentially to also use internal APIs, but those should be separated. So there should be a specific notation as a dependency, as we've seen in the beginning, to just say, I want to apply the public API of Gradle and work on it, or also the internal API. One thing that might be tricky for plugin developers is that we sometimes want to define custom repository types. So you might know that at the moment you can only apply a Maven repository, an Ivy repository, or something that points to the file system. But what if you wanted to deal with custom repository types? For example, you wanted to define, let's say, a repository for Ruby gems or something else, or anything that is resembles a, let's say, Docker repository or registry. Then this will require additional kind of configuration properties that are not specific to Maven or Ivy. But at the moment, there's no public API that lets you actually define these type of repositories. Generally speaking, I think the support for writing language plugins could be improved. So let's say you would want to write your own plugin for supporting JRuby or something else is at the moment fairly weak. You will actually have to resort back to a lot of internal APIs, which is usually not desirable. You can still make this happen, but usually what this leads to is break-in plugins in the future, because as soon as you use internal APIs, they can change with the future version of Gradle, and that's usually not desirable. Test Kit, I haven't mentioned yet, is a public API. It's a toolkit for writing tests for plugins. There could be still some improvements that could happen on that front as well. For example, if you wanted to have specific fixtures, for example, for setting up test projects as part of your test code, or if you want to write, let's say, multi-version cross-compatibility tests as part of your plugin code, then this at the moment is just not provided by TestKit. That's something that you would have to write yourself at the moment. And then one sore thumb that always sticks out here is publishing custom artifacts. So if you wanted to publish specific files from your plugin, then you oftentimes also have to resort back to internal APIs. So you can see in the long run, hopefully we have more public APIs for Gradle plugin development. At the moment, you just have to fall back every once in a while, at least, to internal APIs. One thing that might be tricky for plugin developers is documentation. The Gradle team in the past couple of years has done a much better job in documenting best practices and what goes into writing good plugins. So hopefully there will be even more of that. So the Gradle team will likely work on more user guide documentation. And also as part of tutorials, they will probably write more sample projects. There's a separate site called Gradle Guides, which basically are step-by-step tutorials on different topics. So hopefully there will be more on that as well. You will actually find different tutorials there, for example, for designing, writing, and testing plugins. So if you want to go for that, there's certainly some good resources by now that will help you get started writing your own Gradle plugins. And hopefully there will be more tutorial style kind of guides on that site as well. For example, if you wanted to write a full-fledged plugin yourself, hopefully in the future there will be something that shows you how to do this step by step. There's certainly more we could do for the plugin ecosystem. So you might have touched the plugin portal before. So the plugin portal is the #1 address for publishing your own plugins. It gives you basically a registry for external open source plugins. You can search for them. You can see how to apply them and so on. It gives you additional resources about that plugin. But I would say it's fairly sparse still in terms of the features that are provided by the plugin. I could envision this to become even more feature rich. For example, if you wanted to rate plugins, if you wanted to provide additional documentation as part of your plugin, things like that could certainly be improved on the plugin portal. So hopefully there will be more about that as well. I already mentioned cross-version compatibility testing. So for example, if you wanted to make sure that your plugin is compatible with Gradle 3, 4, and 5, or any version in between, then you would have to write some sort of testing for that, usually for yourself. But I could envision this to become a functionality that is already part of the plugin portal. So once you publish a new version of your plugin, we could basically run a compatibility test suite automatically out of the box in the background. That would then later on tell end users all the versions that your plugin is compatible with. I think that would be super nice to have. There could be additional support by the development plugin that I mentioned before. So any kind of like additional boilerplate code could still be externalized to that plugin. And of course, one big thing that plugin developers, or generally speaking, developers of Gradle always are interested in is better IDE support. I think this has gotten much better in the meantime with the help of the Kotlin DSL, which actually will go final, 1.0 final with Gradle 5.0. I would suspect this version will probably be released in the next 2 weeks. So if you wanted to use the Kotlin DSL, It's going to be a 1.0 final. That's going to be pretty exciting, not only for plugin developers, but also for really any user of Gradle. So if you wanted to go further with writing Gradle plugins, there is a whole bunch of guides by now. Also, there's one sample plugin that you can use, which is called the Gradle site plugin. That's available as part of the Gradle guides infrastructure. That shows you some of the recipes and best practices in terms of a code representation as part of a GitHub repo. So that's certainly something you will want to check out as a good example for writing your own plugins. So that's pretty much what I wanted to cover today. I think we're pretty good in time, 55 minutes. So now we would have some additional time for questions or any kind of additional discussions that you might have. I know that we don't actually have a lot of attendees. So unfortunately, I think the discussion will probably be not very long, but I can see somebody already posted some additional questions.
I guess Artyom is asking something, but in fact, I guess he is able to ask by voice, but for some reason he's not enabling his mic, but we can see questions on chat. So
okay, yeah, let me go through the questions and hopefully I can explain those. I can see that some of those we already addressed, but let me speak about each of them. Artem, I think he said he had to get back to the conference, so he had to drop out, but I can certainly address those questions as part of this the chat here. Okay. So question one is capabilities and conventions. There was an example with two classes, the base side and the side plugin. That's basically the same plugins and only logically divided by capabilities and conventions, not technically. You actually could use that base as a convention rather than a capability. Is that correct? So basically what we did there is that we actually physically separated them. So what you could do if you wanted to really separate them technically is that you start out by writing two different plugin implementations as part of a single project. So the base plugin would basically provide, let's say, custom tasks. It wouldn't necessarily already provide instances of these custom tasks. This is usually something that we would call a capability. So you can keep that code completely separate if you wanted to. And by saying, if you wanted to keep it completely separate, you could basically break up two different projects that have these two different plugins physically separated. And then on top of that, you could have the site plugin, which actually creates instances of these custom tasks by applying the base plugin, and then also add additional conventions. So you can really physically separate them, let's say, into two different jar files if you wanted to do that, if you need to. Usually what you will see, though, is that a base site plugin and a site plugin would usually be shipped as part of a single jar file. And the end user can basically decide which one they want to apply, either the base plugin, which just gives you the custom tasks, or the site plugin, which basically applies both plugins, and then instantiates the tasks that you would use as the end user out of the box. So that's certainly possible. However, you want to split this up either physically, or make them part of a single jar file. That's really up to you. But if you want to really separate them, you can. Number two here in the list, let me see. I can't see my cursor right now. I mentioned dependency hell between plugins. So that's certainly correct, at least at the moment. Is there any convenient way to handle them except fixing plugins and rebuilding from source? So you can't. So what you can do if you wanted to basically remove dependencies that are being pulled in by plugins is that you could basically use Gradle's dependency management to exclude certain plugins. So you could say, Don't use any transitive dependencies of this plugin when you apply it, and then you would be fully in charge of defining your own dependencies. So that's an option. Basically, turn off transitive dependency management for your plugins, which basically lets you manage any external dependencies yourself. What you could do as well is to say, instead of applying a specific version of a transitive dependency that is being pulled in by a plugin, use a specific version that I want to use. That's a certain kind of way to basically mitigate that situation. So a lot boils down to basically Gradle's built-in dependency management. So you can exclude the external dependencies, you can tell Gradle to use a different version, or if you run into version conflict, you can tell Gradle, if you happen to find multiple versions, then use that specific version. So there are a lot of options and a lot of tweaking you can do on that end as well. Third question here is avoiding closures. Let's see what he asks here. Using callable will not break for the example in Groovy closure DSL, but rather just expand things to the level which could be used with Java and Kotlin. Is that correct? Or could the syntax be adjusted? So that's correct. So what Gradle actually does in the Groovy DSL, if you use a callable, it will basically treat it or coerce it into a different type at runtime. So that's one of the magic things that you can do in Gradle. What basically happens is if you use a callable, Gradle will actually notice that this should be treated as a closure if you use the Groovy DSL. So that's without risk. You can just use an action or callable and still use it from the Kotlin DSL as if the type would be a closure. And that's kind of like the beauty of it. You can basically use it from the Kotlin DSL and the Groovy DSL as if it would have been a closure. So that's certainly fully compatible here. And number 4 is it some ground for multi-thread processing or plugins should follow general Java practices here? In general, I would say if you wanted to do some multi-thread processing, then you can. One API that we actually provide that lets you do this with the help of a public API in Gradle is the worker API. So let's say you wanted to process something in parallel multiple times, then Gradle gives you the opportunity to basically create multiple worker processes which are fully separated in terms of their class path, which basically allows you to run multiple things in parallel. So you could probably use Java best practices here, but the better option would actually be to use the worker concept that is part of the public API. So if you want to process things in parallel, rather go with a worker API because you basically fork a different JVM and have complete control over your class path with the help of the public API in Gradle. So that's certainly possible. And that also means that we basically have class loading isolation, and you can tweak the JVM memory settings if you need to. So that's certainly possible as well. Mm-hmm. So hopefully these were the questions that we had. Are there any more questions?
Well, I guess I have some questions, but it's up to you to if you would choose to answer for them now, or you would leave that to answer during another talk, or maybe like a textual explanation in the future. So I have such a few vectors with my questions. So one is really kind of about a roadmap for build automation for the C++ plugins, which we all able to observe on the repository, and with about the story with that for native developers. The second question is somewhat depending on the first, is relates to the best practices of build automation projects where you need to code any native code for libraries in C or C++, which itself have to be called from the Java side using the well-known Java native interface, or shortly GNI. So what kind of approaches, best practices and plugins do we have in the Gradle's ecosystem for that? And the third option is rather about a search of the way when you need to provide like extra specific stuff like a build automation for the language compiler when you put additional language features in your language dialect, or remove something else from the actual compiler, either being a kind of, maybe that's a scripting language like Python or whatever else it implements, it is a runtime is implemented in C, or that is a compiler, or that is a compilable language which is compilable to the bytecode and eventually executed on the GRAM. And for instance, you can take Scala, which is pretty complex, throw out unnecessary issues of the compiler, build your actually build your own version of compilers, then you can write your business intelligence code, which fits that language capabilities, and that goes into actual bytecode. Itself executes like for a microservice and a container, or maybe that's not a microservice, but you have different variations of the language which fits your production needs. And that is might be flexible, it might be fault tolerant, and so on. So like the question is, what is the best way to do that, and if someone already tried to implement such things, and eventually within some compiler plugins, or not.
Okay. So, yeah, let me answer them on a high level. If you have additional questions, maybe you can do this offline as well. So let's first talk about question number one, native plugins. So you might have noticed that in the beginnings of Gradle, there were, I think, like I said, like a C and C++ native plugin. Those have been replaced with new ones that the Gradle team has been working on. They actually wrote a blog post about it that basically shows the basic usage. But as far as I know, right now, it's not documented pretty well. So the only thing you really have is the blog post, and potentially ask them to provide additional documentation. Given that I'm not part of the team anymore, I would suggest you simply open a question on the Gradle forum. But those new C and C++ plugins are built on top of the current model. It's not using the software model anymore, because that's more or less dead. So those plugins are actively being developed. I just don't know what the current status of them is. So I would suggest you ask them, but at least there's current active work on them. And they should by now at least provide the basic functionality for providing, for basically writing native code or compiling it and things like that, doing the typical things that you would usually do for C and C++ projects. So I would suggest have a look at those. And it can also send you the blog post that I mentioned. I would have to dig it up myself to see if I can find it. Then the second question was, what was the second question again? Can you
well, the second question was about the hybrid projects when you need to write both external libraries in C or C++. So basically, generally speaking, that might be just in C, and you have a Java code which should call those external native libraries through the GNI. So you need to work on both the Java code and the native code within the same project.
Okay, so you can basically apply multiple language plugins for a single Gradle project. So there's really no limitation, I would say, even if you have them mixed up in different source sets. So let's say you have a project that has, let's say, 50 modules, and one of these modules is C code, the other one is C++ code, and the other like 47 or whatever, or 48 modules are Java or something else, then I would suggest simply apply the right plugins that provide you the language features that basically lets you then compile code. But even within a single module, let's say you have just a single monolith, you can apply multiple language plugins. And those language plugins will take care of compiling the right things. If you wanted to, and so it seems that you wanted to call native code from Java through JNI or something like that. Right now, as far as I can tell, there's no additional support from the Gradle side of things. So that would be just part of your implementation code. But if you wanted to build multiple languages as part of your project and your automation code, then you can simply do that by applying multiple language plugins. And there should be no like critical overlap, or there should be no interference between these language plugins. Something to try out, I would say, with the new plugins, which I personally haven't used yet for native code. So from that aspect, it's something that I cannot speak about from experience, but what I've done before is that I worked on a project that used Scala and used Groovy and Java as part of a single project. I mean, granted, those are all, and in fact, we actually used native plugins as well as part of the project. So it should be possible as long as you have the code at least separated by source sets or by different modules. So at least from that perspective, it should work actually pretty well. So I can tell you that you can actually mix multiple languages as part of a single project, basically a polyglot project. And the last question was around writing plugins for supporting different languages, if I understood this correctly. Is that correct?
The question was about how to use a Gradle's ecosystem, and particularly the system with the plugins, so maybe implementing some. If you need to actually customize the language, either language runtime, in case of scripting language, or in case of a compilable language like Java, for any JVM language, when you need to customize specific language features to build your own language dialect, and you have understanding of that compiler, and you need a specific practical purpose for that, what kind of roadmap would you propose for such a purpose to combine these activities and also build automation stuff for the actual business intelligence code, which should be applied to that customized language dialect, so it would fit in a one-to-one manner. To make builds which gonna execute on production.
Okay, so let me show you one example here. So what you should do if you wanted to configure other language plugins that already exist is that you basically, in your own plugin, you would react to the fact that another plugin was applied. So let's say this would be some code that you write as part of your own plugin that reacts to a native plugin. Then you would basically say here, if the native plugin is applied, then run specific logic that should reconfigure the native plugins in a certain kind of fashion. Let's say you wanted to introduce your own conventions, or you wanted to reconfigure existing conventions that are provided by the native plugin, and you don't like them, and you want to make them look as if you would basically use your own kind of conventions, then that's a good wrapper. So you would basically say, if you find code that applies the native plugin, then simply pull out these conventions and simply reconfigure them. This could be anything. You could do anything in that execute method that you want. That could mean reconfiguring tasks, reconfiguring conventions provided by the plugin. It could mean providing different values for extensions that are provided by the native plugin, or if you wanted to even add additional tasks that depend on tasks that are provided by the native plugin, certainly easy to do actually, in fact, with this kind of concept. So try to react to the fact that if there was a plugin that you want to react to, and then basically just provide your own conventions, your own configuration. And that also means if you wanted to provide your own kind of setup, let's say you wanted to have your own project layout for your native applications that follow certain standards that you might have in your own organization, then you can put that into the same logic as well. So basically write a wrapper with your own plugin that introduces new conventions or reconfigures existing conventions if a certain plugin is being provided. And if there's no plugin that you can react to, either as an open source plugin for writing specific native code or other languages, then you would basically have to write your own language plugin, so to say. And as I mentioned on one of the slides, you might have to resort back to internal APIs to make this happen, simply because there's simply no public API representation yet. But if you encounter issues with internal APIs, I think my best advice would be here, let the Gradle core team know so they can basically expose public APIs for your own needs. And that's pretty much how I would approach it. So first, try to find a plugin that already exists for the functionality that you need. Then try to reconfigure those conventions if you don't like them or if your standards simply look different. And then if you want to implement your own language plugins for languages that might not be supported yet, then basically write your own plugins that use internal APIs in Gradle or public API if they do exist to implement that kind of functionality. So hopefully that kind of gave you an idea of what you can do. But certainly let me know if there's anything that you think is not covered yet. Optimally, you would just ask the Gradle team to provide the right functionality if it's not there yet.
Okay, thanks. Less or more understood.
Okay, sounds good.
So if we don't have any new questions, and in fact we don't have any other attendees except me and Artyom, so I guess I would have to thank you for your time, and I shall we have a record here, so we guess we have to stop the recording right now, and I probably guess that we can share the recorded video somewhere on YouTube. I'll share the links to everybody who wanted to attend, but haven't arrived in time. Plus, you would have your full access to things that is your kind of your material. So this we would do what you wish with that on your own with your own understanding. Plus, and the same is for the slides. So I guess I shall compose some emails with those vectors which I mentioned, and maybe some contributors to other plugins, and as well, and to check out maybe they would be interested to be speakers for any other events, and particularly as on-site speakers. So in US or in our country or some any other country, so to arrive on meetups and show some workshops, and basically as we can proceed with that stuff to with some practical cases for when we would have a chance to bootstrap that. Since so we have a theoretical background which you gave us, and we could proceed with some practical cases when we would have a critical mass, what specifically would people are searching for and is interested in, or they have some issues which they have some from real world projects, we can poke around that and work with that on sharing some practical stuff on workshops. So like that.
Sounds great. Yeah, thank you so much for having me.